Dear students, this is our second video consecutively. So in this video, we are going to study briefly about dimensional analysis and dimensional formulae. Hope you are making notes side by side as I teach. So in this topic, we are try to learn how to write dimensional formula and what is dimensional analysis exactly is. So it is dimensional analysis is the study of dimensional formula. It is the study of dimensional formula. So let's start. Let's start with simple physical quantities. Let us take mass. Whose SI unit is? As we know, whose SI unit is kilogram. So mass is measured in kilogram. So to write the dimensional formula for mass, what we do is, so it is simple. Okay, dimensional formula is a simple way of writing the physical quantities itself. So we open a square bracket this way, and for mass we write capital M. So capital M signifies mass, and we close the bracket. So this is the dimensional formula for mass. Similarly, time. Okay, let's do for all the 7 basic physical quantities. Okay, number 2 is our length, whose SI unit is meter, which is signifies by small m. So its dimensional formula will be capital L inside the square bracket. So it is a dimensional formula for length. Similarly, time, its SI unit will be seconds, small s, which is symbolically written as small s, which signifies or which is actually a second. Its dimensional formula will be, for time it is t. In similar manner, it is easy to predict. Number 4 it is let us say number 4 it is temperature. The order can be anything. Okay, so temperature it is, SI unit is Kelvin. So it is kilogram, kg. That is Kelvin. So dimensional formula for temperature will be, now it is not T because T is already taken, so Kelvin it is K. Temperature for Kelvin, its dimensional formula will be K. Similarly, current, it is ampere, which is represented by A. So its dimensional formula will be now not C but this A. So its formula will be given by its unit, not by the first letter of the physical quantity itself. So it is the way. So actually, it is simple way. So you cannot ask why C and why not C and why A. It's just a convention only. If it was C, then it was C. It was okay. Nothing to do with that. So it is A now. So we can write it as A. So there is no specific formula to do it. So it is just a convention. So you have to follow this convention. You cannot write C here because it has been followed since long time. So number six is mole. So mole it is like amount of a substance. Physical quantity is the amount of a substance. So it is mole. SI unit is mole, which is symbolically written as MOL, and its dimensional formula will be in square bracket MOL. So it is a dimension. So you make notes side by side with this video. Last one, it is luminous of intensity, which is not very much important to this level. Luminous of intensity. So its SI unit is candela. Candela, and its dimensional formula will be in square bracket CD. So these are the dimensional formula of the 7 basic quantities. Now we move a step forward from here. So these are the basic physical quantities. Now we will talk a bit about derived quantities. So derived quantities. So what are derived quantities? So derived quantities are derived physical quantities, or simply derived quantities are the combination of basic quantities. So one or two basic quantities combined to form derived quantities. For example, let us take, we can combine mass, which is a basic quantity, and length, which is again a basic quantity. So this is a basic quantity, and length, this is also a basic quantity. So we can combine these two basic quantities to get a derived quantities, that is distance, isn't it? That is, okay, not mass. Okay, let us combine time, which is basic quantity, and length, which is again a basic quantity. So these two can combine, time and length can be combined to get a speed, isn't it? Because speed is distance is length, distance by time. So distance is basically nothing but its length. So distance can be measured in terms of length. So this is also a basic quantity, this is also a basic quantity. So you combine two basic quantity to get a derived quantity, in this case, which is speed. So there is a derived quantity. So there are numerous derived quantities. From 7 basic quantities, you can make or you can get numerous derived quantities. And for example, I have given one of them is speed. So what is the SI unit of speed now? What is the SI unit for speed? So SI unit for speed will be the combination of SI unit of distance and time. So distance, the SI unit of distance is meter, or SI unit of length is meter, divided by SI unit of time is seconds. SI unit of time is seconds, which is S. So it is basically meter by seconds, or if you take seconds to the numerator, it will be second inverse. So meter second inverse, or meter second to the power minus 1. So SI unit of speed will be meter per second. Okay. Now what will be the dimensional formula? For speed. What will be the dimensional formula for speed? So dimensional formula for speed will be meter. So you have meter in the SI unit of speed and seconds in the SI unit of speed. So meter is basically length, isn't it? Meter is a measure of length, so it is L in the bracket, and second is a measure of time, so time in the bracket, but time has an inverse of 1 here, so time inverse 1. So this is the LT inverse 1 is the dimensional formula for speed. Okay, one more. I want to do one more dimensional formula for one more derived quantity. So let us do, so another derived quantity, let us take, okay, you can take any derived quantities, that is listen, force. Force is basically, force has a different forms. In this I want to write force as mass into acceleration. Okay, mass is a first thing you have to do is you have to break the force into basic quantities. So mass is a basic quantities, so leave mass as it is, and acceleration is nothing but it is velocity or speed, the same things, velocity or speed divided by time is your acceleration. So mass is a basic quantity, so leave it like that. Velocity is not a basic quantity. Velocity is, or speed is, distance by time. This is velocity, and one more time in the numerator. This time here velocity is distance by time. Now see, mass is a basic quantity, distance is measured in terms of length, so length is a basic quantity, time is a basic quantity, time is a basic quantity. So you have break force into all basic quantities. So rewrite this one. So mass into, so distance by time, so this time has 1 in the denominator, so 1 by time. When you take it, like when you multiply this one by this one, so it will be 1 by time. So mass into distance by time square, so time into time square. So mass, SI unit of mass is meter, SI unit of distance is SI unit of mass is kilogram, SI unit of distance is meter, SI unit of time is second, so second square. So kg meter by second square is the SI unit for force, or kg meter. When you take second square in the numerator, it will be second inverse 2. So this is the SI unit for force. So force can be written as kg meter second inverse, which is also known as Newton. So this particular unit is also known as Newton. So Newton is the SI unit for force. So 1 Newton is 1 kg meter second minus 2. So Newton is the SI unit for force, which is equals to kg meter second inverse 2. Now what will be the dimensional formula for force? Dimensional formula of force. So firstly you have to open the square bracket. Now kg is the SI unit of mass, so capital M. Meter is the SI unit of length, so L. Second is the SI unit of time, so time inverse 2. So this is the dimensional formula for the force. So this is how you represent a physical quantity. So in this case, force with a dimensional formula. So now I want you to do some homework and kindly send me in the WhatsApp or in the group itself by completing the solution. So you have to send me the entire process by clicking from your camera of the cell phone. So please send all of you. So homework are, so write the dimensional formula formula for work. So you need to send the dimensional formula for work, velocity, kinetic energy, what else, pressure, uh, last one is what else, okay, acceleration. So kindly complete it and send me in WhatsApp in the group itself, all of you. Yeah, thank you. So this is it for today. So we are going to continue our discussion tomorrow. Thank you.